Hello class. Okay, today, now, let's talk about gravity. Let's talk about the International Space Station, right? The International Space Station, it's up there in space right now. It's orbiting Earth, right? SpaceX just launched, SpaceX is launching there now. The Russians, where we were using, the United States was using the Russian vehicles to transport our astronauts. Of course, there's an international there's a whole contingent of astronauts from all over the world there. It's an International Space Station. And then recently, of course, SpaceX did a launch. So we have an American company now launching to the International Space Station, and not just the Russians. So, of course, we all know that when you look at video of that, or you look at older videos when astronauts were on the space station, or the space shuttle, I'm sorry, the space shuttle, they're floating around, right? They're floating around, and you ask a lot of people, well, why are the astronauts just floating around? And inevitably, some people will say, well, because there's no gravity in space. Okay. Well, let's talk about that. So let's think about that. So the International Space Station and the space shuttle, they were both about 350 miles or so above the surface of the Earth. That's not so far. How long would it take you to drive 350 miles? 5 hours maybe, right? Thereabouts on the California freeways. So if you just go 350 miles up, some people are saying, well, there's no gravity there. A mere 350 miles. The moon is over 200,000 miles away, right? Way more than 200,000 miles away. But the moon is orbiting Earth. We know that. It takes about a month, right? So if there's no gravity at a mere 350 miles, which is right above the Earth's surface, then what is keeping the moon in orbit even though it's so far away? Wow. All right, what are you going to do with that one? Well, the answer, of course, is there's plenty of gravity. Even though the moon is so far away, well over, I forget the exact number, 250,000 miles. It's over 200,000 miles away. Yet, there's enough gravity that it remains in Earth's orbit, right? So that would imply that if you're even closer, being so close to Earth, a mere 350 miles above the surface, there would be gravity. Of course, we have gravity, right? I let go of my pen, my magic marker, right? Gravity pulls it down, right? So we know there's gravity. Yet we see the astronauts floating around just that mere 350 miles away. So let's talk about that. Let's talk about it. Okay, so let's talk about gravity for the first thing. So we've already discussed that the closer you are to Earth, the stronger the gravity would be. That makes sense. If you go really far away, if you went way far out into space, you wouldn't feel Earth's gravity anymore. But you got to go far, right? When the astronauts were on the moon, it was the moon's gravity that held them. They weren't worried about Earth's gravity anymore. They were far enough away. In fact, there's a point where if you were flying to the moon, where eventually moon's gravity would take over. You wouldn't worry about Earth's anymore, right? Then you would land on the moon. So the way it works, the way gravity works, it follows what is called the inverse square law. And the inverse square law, I'm going to show you a diagram later on the inverse square law. But just for right now, I'm just introducing this term. If something is twice as far away, the gravity goes down by 4. And it's called the inverse square law. There's math, 1 over the amount of gravity squared. We're not going to do that math. But just know that if the moon was twice as far away than what it was, we're always going to use the same example just to keep it. If the moon was twice as far away as it is right now, the force of gravity from Earth would go down by 4. So that's the inverse square, because it went twice as far away. 2 squared is 2 times 2 is equal to 4. And it's inverse, meaning that it gets smaller. So that's the inverse square law. So we'll do more of that later. You're going to read about it in a book. You're going to see another video. But I'm introducing that term. So let's keep that in mind. So there's enough gravity for the moon, which is way far away. So what's happening so close to our surface? So let's keep in mind that the International Space Station and the space shuttle, they were orbiting at 17,000 miles an hour. That is fast, right? When you're driving your car, you're going, what, 60, 65 miles per hour? Imagine if you're going 17,000 miles an hour, right? It only takes 90 minutes for the International Space Station to orbit Earth once. They're about 90 minutes, so that's an hour and a half. It's going really fast. What if you were driving so fast you went around the Earth in an hour and a half, right? That's how fast it's going. It's going that fast to balance the force of gravity, right? It's going around. So the force of gravity is pulling on the International Space Station, but it's going fast enough. So it's just like, you know, there's that hammer throw in the Olympics where big strong people, they have that object on the end of a wire and they pick it up and they twirl it, or even if you had a ball at the end of a string, you twirl it. Well, the ball wants to go away because the faster you twirl it, the more tension there is. So if you're twirling it really fast, the ball wants to go away, but the string is holding it. Well, that's what's happening in orbit. But instead of a string, you have gravity. And the reason they say rocket science is so hard, you have to be going exactly the right speed to balance the gravity at the distance that you are at, and that's the way it works. So if you're 350 miles up, you have to go 17,000 miles an hour to balance the force of gravity. If you're farther than that, you go slower because the gravity gets a little bit weaker according to the inverse square law, and then you go slower to balance the force of gravity. That's the way it works. So let's look at some pictures, diagrams, and other such things. So here we have. So here's the picture in your book, in your text, right? I have a hard copy. You can look online. It's figure 3.11 in the textbook for this class, right? So you're going to read this, right? It's on your reading assignment, so make sure you do that. And let's do a little illustration right now. Yay! Felix is going to draw for us. He's such a great artist. You are in luck. You have the benefit of my artistic talents. You are lucky people. Okay. So Isaac Newton, right? Isaac Newton was alive like 400 years ago, a long time ago. He came up with this. So this concept's been around forever, right? So let's say you have Earth, and there's a mountain on Earth, and you have a cannon. You have a cannon up on this mountain, right? And it's on Earth, and if you shoot a cannonball, what's going to happen? The cannonball is going to go some distance, and it's going to hit the ground. We're used to that. When you watch an old pirate movie, they shoot the cannonball goes, and it lands in the ocean or it lands somewhere, it hits the ground. Well, what if you shot it with more power, more force? Well, it would land somewhere else. What if you shot it with more? It would land somewhere else. What if you shot it really, really, really hard? Well, we know, it would leave our orbit, right? If you shot it fast enough, it would go out into space, right? So let's do it a little bit less than this. So we'll do it a little bit less. You shoot another one, and it lands here. So you do it less than this, but more than this one. So you do it right in between. So it goes right. So it's going, and whoa, what's happening? Whoa, what's happening? That is orbit. It's going at precisely the speed that you need at that distance that it is from Earth to be in orbit. That's what orbit is. This is what the International Space Station does. It is going at 17,000 miles an hour, so for its altitude, the distance it is over Earth, it has to go that fast. So here, the theory that there's no gravity. If you had Earth, right, and they launch a lot of things out of Florida, right? So say you have the United States, there's Canada, right? Here's the United States, here's South America, right? So let's say that they launched from the United States. If there was no gravity, all they would have to do is go, and then that's it. The space station would just stay right there in that spot. It would not orbit at 17,000 miles an hour if there was no gravity. It wouldn't need to. It would just go, and it would stay there. if it went 17,000 miles an hour, it could just go out here someplace if there was no gravity, but it doesn't. So that's another thing. If there was no gravity, you could just launch 350 miles up and it would just stand there still. It wouldn't have to orbit, but it doesn't do that. What it does is it orbits the Earth at 17,000 miles an hour because it's balancing gravity. Do you see that? So let's talk, okay, so why are they floating? Why are they floating? Well, you ever been in at an amusement park? One of those rides. I was in a ride once when I was a younger man, right? At one time I had a date, and we're on this ride where we're sitting in this thing, and all of a sudden, like, it just drops, and you're just in free fall, and like your stomach goes up into your chest. You're like, oh my God, right? Or even if you're on a roller coaster, when you're going down, like your stomach goes into your chest. There's this plane, they call it the Vomit Comet, where NASA has this plane where they train the astronauts, right? Where the plane is going, and then it nosedives, and you for a minute or so they don't have any, their weightlessness, but then they eventually, because they're going down, they have to go back up so they don't crash, right? So what it is, that's called free fall. If you've ever been on an airplane and there's turbulence, right? And so when you're just going, that is called free fall. The amusement park rides, or if you're on an elevator and the elevator starts to go down, you feel just that little bit, or that is called free fall. So the astronauts, what happens is that they're going at just the right speed, and they're going, and they're falling, but the Earth is round and it's curving away. It's right here we can see it's falling down. It makes sense. So here, if the astronauts, were landing, you would feel that free fall. So it all makes sense for this one. It makes sense for this one. It even makes sense for one here. Well, right here, it's the same thing, but it's just in this perpetual free fall. So tell people, this is one of the biggest misconceptions, that, well, there's no gravity in space. That's why the astronauts are floating. That's true if they're going to the moon and they're really far away. But for just the mere distances of the space shuttle or the space station, which are only 350 miles above Earth's surface, no, there's plenty of gravity. They are in free fall. Make sure that you read that section in the book. That is that. That's all, okay? We'll talk later. Bye-bye.